Okay, so now we're recording again. So Sophie says she doesn't have any questions. Braden, Haley, Mateo, and Smiley, do you guys have any questions for me on yesterday's stuff?
No.
Okay. So
No.
we're going to keep moving backwards like we did yesterday. So like we know, oh my gosh, I can hear myself in my speaker and it's kind of driving me nuts. So anyway, we know that we have x. And right here we have x squared. So if x is 10, then x squared is 10 by 10, right? And then, who knows how many this is? Holy cow, it's huge.
100?
No, this is 100.
100.
10 by 10 is 100. So this is 10 times 10 times 10. So this is 1,000. So yesterday we just did square roots. I said if you have a square that's 100, this is this. If you were going to count it, 1, 2, 3, you would count 100. I have no desire to do that. But if I say if you have a square that's 100, how big is the side? And that's called the square root. You guys see why it's called the square root? There's the root. And that's what we start with to get the square, okay? So if I have 1,000, right? Which I do. Holy cow, that's like really close to my camera. You know, I'm going to switch it. I'm going to unpin this real quick so you guys can just see it. How do I unpin it? There we go. Remove pin. Sadie's here. Hi, Sadie. Okay. So if I have, I need to mute it over there. Okay. You guys can't see me big. You're supposed to be able to see me big. I'm going to pin that one. All right. So I have this big cube here, right? So if I said I have a cube, that's 1,000, which this is. If this was actually filled with little squares, it would be filled with 1,000 of them, right? If I said if I had a cube that's 1,000, what does it start with? What is the length of one edge on my cube? And it's one of these little guys. So we have 10 by 10, which is 10 squared, right? So 10 squared, but then we take that and move it this way, and we get 10 cubed, okay? So today, we're going to go backwards from the cubes. Just like yesterday, we went backwards from the squares, today we're going to go backwards from the cubes. So like if I say I have a number, I don't know what number that is. Some number, we're going to call it x, times itself 3 times, and it's not times 3, it's times itself, equals 1,000. Well, we just saw that that equals 10. 10 times 10 times 10 equals 1,000. Isn't it crazy how big it gets so fast? Like it's just nuts. So if I said, okay, what number times itself 3 times equals 8? What do you guys think that would be? Who has an idea on that one? You can either, I'm going to pull up my chat window and put it in the corner over here. You can message me if you don't want to talk, or you can say it out loud. I don't even care. You guys can just toss out ideas. What times itself 3 times equals 8? What do you think? Anyone? Have we just completely, can you guys hear me okay?
Yeah.
Okay, so you can hear me. Thank you for whoever said that. I think that was Braden. Thank you, Braden. Okay, so you guys can hear me. So what number do you think multiplied by itself 3 times would be 8? Just toss out numbers. It's going to be smaller than 8, right? What's a small number?
2.
2. Let's try 2. So 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. Good job. It was 2. All right, should we try another one? Let's try 27. What number multiplied by itself 3 times would equal 27? What do you think? Somebody not Braden. Anyone have an idea? If you choose a number and it's not the right number, then that's fine.
9.
Let's try 9. Ooh, Sophie, because 9 times 3 is 27, right? So what's 9 times 9 times 9? Well, 9 times 9 is 81. And I don't know what 81 times 9 is, so let's find out. Well, 729. So did that work? Nope, it was a little bit too big, wasn't it? So I love that you did that though, because we know that 9 times 3 equals 27, but 9 times 9 times 9 is way, 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 way bigger. If I try, let's try something smaller. Let's try 4. 4 times 4 times 4. Does that equal 27? Let's see. What's 4 times 4 is 16. 16 times 4 is, I don't know, 64. So even 4 is too big. So let's try 3. 3 times 3 times 3 equals, well, we have 3 times 3 is 9, and 9 times 3 is 27. So 3 cubed equals 27. Now, yesterday, when we were doing square roots, we would say, like, the square root of 4 equals 2, or the square root of 9 equals 3. This symbol, called a radical, is one of the things that has what we call invisible math, okay? So in invisible math, like 3 is really 3 over 1, right? And 3 is also 3 to the first power. It's really 3 to the first power over 1. We never write that stuff. It's just invisible. So on this radical, there's actually an invisible 2 to tell us that we're taking the square root. But when we have a cubed root, we need a number 3 there to tell us that it's a cubed root. So when I have this number, if I put the number 64 under the radical with a cubed root, the cubed root of 64 will be, what did we just discover? 4 times 4 times 4 is 64. So the cubed root of 64 is what?
Four cubed.
It's just 4. You don't say 4 cubed because you say the cubed root. What number times itself 3 times is 64? It's 4. Let's do another couple of these. If I have the cubed root of 512, okay? So I have the, uh-oh, my thing froze. You guys can hear me, but there it goes. Boom, like magic, it just popped up. All right, so I have the cubed root of 512. So something times something times something equals 512. Anybody have any ideas on what that one might be? Anybody want to toss out a number for us to try?
Nine.
Let's try it. 9 times 9 times 9. Well, 9 times 9 is 81. Times 9 is 729. So you're a little bit too big, but not, I mean, not crazy much too big, right? 729 is bigger than 512, but it's not a ton bigger. So should we try 8? 8 times 8 times 8 equals, okay, so 8 times 8 is 64. 64 times 8 is 512. There it is, excuse me. So 8 times 8 times 8 is 512. So the cubed root of 512 is 8. So let's do one of these. If I know that 4.5 times 4.5 times 4.5 is 91.125, then what is the cubed root of 91.125? What do you guys think?
4.5.
4.5. Good job. Okay. So what about, so yesterday, when we tried to do the square root of like -16, we discovered that that doesn't work because -4 times -4 is +16, right? And it just doesn't work. So when we say, you know, give me the square root of a negative number, we just say that is not possible. There's no real number that will work there. But what if I say the cubed root of -8? Can we do that? What do you guys think? Give me a thumbs up on your self there if you think that that is possible.
Can I please get Pace and Adams to come to the office? Pace and Adams.
Sophie thinks it's possible. Mateo, I'm going to be calling you Jessica because it says Jessica on your thing. Mateo thinks it's possible. Sadie thinks it's possible. All right. Let's see. If it was possible, what do you guys think it would be? We know that the cubed root of 8 is 2. So should we try -2? Let's try -2. So -2 times -2 times -2 is, let's see. Okay, so what's -2 times -2? Who can tell me that?
+4.
+4. So we have +4 times -2 is -8. Nice. So can we have the cubed root of a negative number? We totally can. So I'm just gonna do this. This isn't part of our lesson, but what if we have the 4th root? What if we have the 4th root of like -16? That's gonna be 2. Okay, so if I say -2 times -2 times -2 times -2, because the 4th root is what's multiplied by itself 4 times. -2 times -2 is +4. +4 times -2 is negative. Okay, so +4 times -2, that one's going to be -8. And then -8 times -2 is +16. Can we do a 4th root?
No.
Nope. So you can do odd numbered roots of negative numbers. You cannot do even numbered roots of negative numbers. Okay. Does that make sense?
Yeah.
Okay. Makes sense to Sophie. If it doesn't make sense to anybody else, you guys got to speak up. You're going to let Sophie speak for you all. All right. So let's look at this assignment. It's not tremendously long. I want you to do 1 through 10. Now, when I say without a calculator, I mean don't use the cubed root button on your calculator, okay? I want you to try to figure out, now some are squares, and some are cubes. Like what number times itself equals 64? And you might know that, and you might not know that, but I want you to play with it. Let's say you think it's 7. So like 7 times 7 is 49. That doesn't work. Let's try 9. 9 times 9 is 81. Oh, wait, it's not 130. 9 times 9 is 81. That doesn't work, so let's try 8 times 8. Sure enough, so x equals 8, okay? Oh, my hands froze again. Check it out. Well, there's just wait. That's so weird, watching my hands like, and that's not what I'm doing in real life. There we are. So let's look at a cubed one. We know that x cubed equals 216. I can't look at that and just know what it is. I don't know if you guys can. I'm not that cool. So I'm gonna just try something. Well, let's try, I don't know. Who wants to give me a number to try? Anyone have a number they want to try? Let's try 4. I don't know. So 4 times 4 times 4. So we have 16. 4 times 4 is 16. Oop, not 44. 4 times 4 and then times 4 is 64. 4 was not even close to being big enough. Let's try 6. 6 times 6 times 6. 216. Yay! So x equals 6. So that's how I want you to do these, okay? Now on the back, I'm going to let you calculate these with your actual calculator, okay? Now, we learned yesterday about rational and irrational numbers, but not very many of you were here. I love how many of you are here today. It just, makes me happy. Those of you who were here or who might know, who can tell us what a rational number is? Anyone want to try that one? No takers? So there are rational numbers and there are irrational numbers. Rational numbers are whole numbers, like 5, 10, 1,063. Those are all rational numbers. Fractions are also rational numbers. 1/2 is a rational number. 1/3 is a rational number. 16 23rds is a rational number, okay? So I'm going to put 1/3 in my calculator though, and I want to show you what we get. 1 divided by 3 is 0.333333, and it literally goes on forever. It will never ever end. So it is a rational number, but it goes on forever. Do any of you know what makes it rational even though it goes on forever?
I don't know.
You know what? That's okay that you don't know. It's because it repeats. Let's look at 16 divided by 23. That one's going to be an interesting fraction. Oh, 233. No, 16 divided by 23 is, all right, so look at this. It's 0.695652174. I haven't found where it repeats yet, but it's going to repeat eventually. They all repeat. Maybe you'll have 0.427427427. They're going to repeat. An irrational number, like if I have the square root of 8, 2.828427125, they never end and they never repeat. Most of your square roots and most of your cubed roots are going to be irrational numbers. The square root of 8 is an irrational number. Now let's look at the cubed root of 8. Oops. The cubed root of 8, is that rational or irrational?
Rational.
Totally, that's a rational number, okay? And let me teach you how to do the cubed roots. Now, if you have this kind of calculator, it'll work on this kind of calculator. If your calculator is different, you're gonna have to figure out how to do that. If you have an Apple phone, you can do it on the calculator. If you turn it sideways, it pops up and it has a little number 3 on the radical. I think there have to be like if you Google cubed root calculator, it will help you with that, but you have to be able to do a cubed root, okay? So let's just choose it. Somebody give me a random number.
11.
11, that's a great random number. So 11, so if you look really closely, right here on this key, it says y to the x, and then in yellow, it has a little x over a little radical and then a y. So to hit the yellow ones, you need the second key. This means the second level of keys. So you hit second, then you hit the y to the x button, and then to tell it you want the cubed root, you hit the number 3. And then that right there is the cubed root of 11. If I multiply 2.223 times itself 3 times, I will get 11. Now, what do you guys think? Is this rational or irrational?
Irrational?
Irrational. Most of these are going to be irrational, okay? Because they're not going to repeat. So if it doesn't ever, ever, ever end, what in the world do you enter in on your assignment? Do I expect
A rounded like version of it?
Yeah, like how do we round this? Because you cannot type this in forever and ever. That's a little bit ridiculous, right? You would just round this to the nearest hundredths. So 3 is smaller than 5. So I'm going to say that the cubed root of 11 equals 2.22, and that it is irrational. You get 2 points for telling me this, and you get 2 points for telling me that. So if you skip the irrational part, it's going to be -2 on everything, and your score is going to go down really, really fast. I'm finding a lot of kids skipping a lot of problems on their assignments, and then your score just goes down so fast. Because if you try it and you get it wrong, it's -1. If you don't try it, it's -2. So be aware of that. Do you guys want us to do some more practice ones, or do you feel good?
I feel pretty good.
Okay, Sophie feels good. Everybody else, Mateo, Haley, Braden, Sadie, and Smiley, give me a thumbs up if you feel good, and don't give me a thumbs up if you want me to do more. Except Smiley, I think you're having a hard time with the thumbs ups. Sadie's feeling good. That's good.
I feel good.
Braden feels good. I feel good. Haley, how you feeling? Do you want me to do another couple of Smiley feels good? There is also, I do have a video for this lesson, guys, and I have different examples on the video. So if you're like, I just don't know. I don't remember what examples I did on the video because it was seriously like 3 days ago that I made that video. There are different examples. So if you're working on it and you're like, I am so lost, you can watch the video. I know some of you have had a hard time watching my videos. So I've started putting them on YouTube. Sophie, were you able to watch the Zoom video yesterday? Were you finally able to get that one to work?
Yeah, I went onto YouTube to watch it. It worked out perfectly.
Millions of dollars on my YouTube channel, guys. I'm so excited. Everybody's going to watch my algebra videos, and I'm just going to be so rich. So excited. Not really. But I'm glad you were able to watch that. So they'll be on YouTube, and you guys can watch them there. I will probably post this one too, since we went through different stuff. So you can watch this again, and then you can watch the other video, so you can have lots and lots of examples. Anybody have any questions?
No.
Okay. Oh, I was going to tell you guys, a lot of you have missing assignments, like a lot of you. So if you have missing assignments, Thanksgiving break is a really, really good time to make those assignments up. You can work on them and submit them during the break. Don't do 5 of them and submit all 5. Do 1. Let me correct it, make sure you know what you're doing, and then we'll move on to the next one. And if you're working on it and you're like, I just can't even figure this out, I can help you. You can email me, I can help you. I can either email back or we can have a little Zoom or something. But even though we don't have school, I'm still available. I'm not going to be like instant there, right? Like you email me at 1 o'clock, I'm not going to email back at 1:01. But you email me at 1 o'clock, I might email back at 1:30 and be like, okay, let me help you with your math. Then I'll help you with your math the best that I can. Sometimes I'll make little videos and send them to kids. And sometimes I just answer in print. Sometimes we'll hop on and do a little Zoom if you want to. There's lots of different ways, okay? But you just have to ask because I don't know if you're struggling. I don't look in my kids' windows to see if they're doing their math. Sometimes I wonder if I should, but that would be really creepy and horrible. So we're not doing that. All right, have a good break. Get caught up, guys. It makes me sad that so many of you are not doing well. Okay, let's catch it up, and then we'll start December off right. Sound good?
Mm-hmm.
All right. See you guys.
Bye.
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 Bye.